Yeah, hi everyone. This is our project Whack-A-Mole and I'm Arnav.
My name is Pri.
I'm Ravisa Shairat.
And I'm Vansh.
So this is our game logic modules. We get the original code from the GitHub. We have most generators modules based on the difficulty levels. We have the hit modules to check if the user hit the most or not. And the last one is how to calculate the score and send the score to the VGA display to display the score on the screen. And in this module, the main part is we receive the pause signal from the time counter to stop or start generating the most, and we receive the tab input to check which holes the user hit, and we have the difficulty levels, and we have the start button, and we will output the moles and the score for the VGA.
So this is our module for our letter map in which we have assigned different x and y coordinates for different segments of one letter. So for example, P1 has different start and end xy coordinates. Later in this code, all the segments of P are summed together to make the combined letter P. Basically, the main idea for this module was to first make the letters in a 5 by 5 grid and then initialize them in a different module, which is VGA2, which is also our displays the first screen of our game into a 60 by 60 grid or 640 by 480 grid, which is the exact dimensions for our VGA display. And as you can see, the entire word gets displayed once I call the previous module letter map into this module. And how I did that was by changing the width from 5 and 5 to 50 and 50 and 40 and 40 for different words.
This is the module for the game screen. It will basically creating a mole and holes and also the time and the score. For the mole, we'll be using this to display the shape of the mole, and we'll just be assigning each mole to the location of each hole, and it would just display once the hole from the game logic is one. And this is pretty much how we were able to make the moles appear on the holes. And for this module, it is to display the last screen. We'll be having the final score and also the restart button that when we click, it would just go straight to the first screen.
Yeah, so now let's start with the mouse module first. So in the mouse module, we can see we have like a few inputs, just a standard clock and reset button. Now these two are the debouncer switches that we need to filter out all the noise, and these two are the inputs from the PS2 controller. This is the PS2 clock, and this is the PS2 data signal. And these two outputs, this shows the button clicks, the left and the right button click, and this shows the relative x and y velocity. Now, if we go down, we can see here that we're also using other modules. So this is the RxTX module, which is the receiver and the transceiver, and these two are the debouncers. So we're using all of this to transmit all of this data back to our VGA screen. So if we go to the other module, we can see here that we're using a separate receiver and a transceiver. So in the receiver, we've actually made an FSM where we can go through each data signal. So we can go through the start and stop bits, we can go through all the data bits, and we can go through the parity bits each time a new data word comes up. So there are 33 bits of data each time, and we have to go through them in 11-bit chunks. So this is the 8-bit chunk of the 11 bits, and we have the start and stop bit and the parity bit. And in the transceiver, we just make sure that after every clock signal, we wait and we transmit some data back to the PS2 controller to make sure that we are receiving everything correctly and all the movement is working out fine. and this is the debouncer code to just make sure that no extra noise is coming through. So all of these are combined together in this mouse module, and these are the outputs that we give out. And then once we go back to the VGA file, we can see here that we're using this in two different instances. So at first we're calling the mouse module here, and then we're using a mouse XQ, mouse YQ, and the mouse color to just keep track of the absolute x and y coordinates of the cursor and the color of the cursor. So here we're using registers to always update the absolute coordinates with the relative change in the coordinates. So x and y are the x and y velocity or the relative change, and depending on the sign we either add it or subtract it. So it either goes top bottom for y and it goes right left for x depending on the sign, which is x8 and y8, and we add or subtract those to the absolute coordinates. And then we also keep track of our click. So if the left button is clicked, which is button 0, then we tap a specific mole depending on the coordinates of the specific mole. So we have hard coded that, and yeah, and we keep track of the colors. So and in the end, to just keep the cursor in the VGA screen, we've added another if statement here. So mouse on is basically just a condition where each pixel, like the pixel x and the pixel y, if they are in the specific square range, so x coordinate plus 16, y coordinate plus 16, 16 is the size of the mouse cursor, then the color, the VGA RGB are the color of the cursor. So with this we make sure that the mouse cursor is always on top of everything else, because the if statement is in the end and it's rendered properly. And yeah, that's it.
So this is our time counter modules. We create a timer for 30 seconds. At first we slow down the clock from 100 million hertz to 1 hertz, which is exactly 1 second. And once it receives the start signal, it will start to count down the time from 30 to 0. So our top module, we combine all of the module we want to use. So we have to display all of the VGA at the same time, and then we create a FS finance state machine to switch state from the first page to the next one and to the end game. And once the user click the restart button, it will go back to the start pages. And we also include the time counter and game logic to generate the modes and the score for the VGA modules.
This is the demo video of the Whack-A-Mole game. So to activate the mouse cursor on the screen, we need to flick these two switches, which are also the debouncer for the left button of the mouse. So as you can see, once I flick those switches, there's a green square on the first screen, and as well as on the other screens, which represents the mouse cursor. It also overflows if you go in the extreme left and right positions and top and bottom. So now we're actually going to start playing the game. First we select the level of difficulty. So I'm going to select level 2 and hit play. So on the top left corner of the screen there is an inverse counter which goes from 30 to 0 seconds, and also on the right corner there's the total score while playing the game. So I'm going to start hitting the moles now, and the score is going to increase by 3 points every time I hit one mole. So that's the difficulty on level 2, and that's our final state of the game, which has the total final score and a restart button to go back to the first state again. So that was our demo for our game. Thank you.